C'est sur cette base qu'on a pris ce projet.
So, the purpose of the project is to protect the biodiversity and the environment. So the project is about early detection of bushfire.
So can you explain how your system communicates with the sensor to detect bushfire?
It's always public.
Comment utiliser le capteur pour détecter les feux de brousse?
Donc, pour détecter les feux de brousse, nous avons un certain nombre de capteurs, à savoir des capteurs de température, d'humidité, de CO, c'est-à-dire monoxyde de carbone, et de CO2. Donc, du coup, ces capteurs auront pour objectif de prendre les données environnementaux. Ces données, à partir de ces données, on va essayer d'évaluer les risques à un seuil donné, à un seuil de température, de CO, de CO2, d'humidité et ces consorts, on déclenche des alertes. Donc, ces données seront plus tard utilisées, seront plus tard renseignées au niveau de la base de données, plus précisément au niveau d'un Google Sheet. Et après, on va récupérer ces données sur une plateforme pour une visualisation un peu graphique, adéquate à tout le monde.
So they use 4 sensors to collect data about dioxide of carbon, carbon monoxide, and humidity, right?
La température, puis le CO2,
Yeah.
l'humidité.
Okay. So collected data are used for les données collectées sont utilisées comment pour la détection?
Les données utilisées sont envoyées au niveau d'une base de données, un Google Sheet.
Okay.
Et
Collected data are centralized in the databases.
Et à un seuil donné, si la température atteint un seuil, le CO2 atteint un seuil et l'humidité aussi atteint un seuil, on déclenche une alerte au niveau de la plateforme.
Okay, and depending on the threshold, they send alerts.
Did you encounter any challenges while coming up with this project or implementing this project? And if so, how did you overcome them?
Avez-vous rencontré des difficultés, des défis et comment les avez-vous surmontés?
Oui, je dirais qu'on a rencontré des difficultés d'abord pour trouver les composants, vu qu'on a rencontré beaucoup de difficultés à trouver les composants en local chez nous. Donc du coup, on est passé par plein de moyens. Je dirais qu'ils ont pris beaucoup de temps. Ils ont pris beaucoup de temps pour trouver ces composants. Et à part ça, on a eu quelques autres difficultés. Des difficultés liées à l'impression, parce qu'on devait imprimer nos trucs, des impressions 3D. Donc du coup, on n'avait pas tout ce qu'il faut pour faire les trucs comme il faut.
So IoT devices were not available, so it took a long time to buy them, and also they faced difficulties for printing the device. So they use 3D printing, so they didn't have all this. Yeah.
What would this project look like if you were to make any modifications to it? How would you scale it up?
Comment pouvez-vous améliorer, passer à un autre niveau avec ce projet?
Je dirais qu'en Afrique, les terrains sont un bien très important parce que nous vivons primordialement des cultures. Donc du coup, pour améliorer ce projet, on pourrait intégrer des systèmes intelligents, des IA, qui pourraient essayer de prédire des données, essayer de créer des données aléatoires pour simuler des cas.
Pour simuler?
Non, pas pour simuler, essayer de créer. Je ne sais pas comment expliquer cela. On pourrait utiliser des IA, on pourrait intégrer des IA qui pourront essayer de simuler des données.
Simuler des données. future are very important, so they depend on the environment. So he said they can add some future to integrate data for simulation, but which kind of simulation exactly think he's thinking about?
So give me a real world scenario where or how your products can be deployed.
Et il faut donner un scénario ou bien expliquer comment on peut déployer votre projet dans la vie réelle.
Bon, notre projet, c'est un système qui est mis en place comme des panneaux solaires. C'est un pilier, un pylône. Et à la tête, il y a un panneau solaire. Donc, du coup, on a à peu près un poteau, un fer sur lequel on a placé nos composants, un boîtier électrique dans lequel se trouvent les microcontrôleurs, le SP32, nos capteurs et à peu près tout. Donc, du coup, le système est autonome, donc ça peut marcher à n'importe quel niveau, que ce soit dans les campagnes, que ce soit dans les zones reculées et tout.
So the system can be used everywhere, in city or in villages. So the main device is a pillar, and at the top we have a solar panel. So he said all devices are together, so it can be deployed everywhere to collect data.
Can you give us the rationale as to why you, or behind why you chose the specific sensors that you've implemented in your project?
Okay. Les raisons qui ont motivé le choix des capteurs que vous avez utilisés et implémentés dans votre système.
D'accord. Donc, les raisons. Nous savons très bien que lorsqu'il y a fait de hausse, l'émission, il y a augmentation de dioxyde de carbone, c'est-à-dire du CO2, il y a aussi la température qui augmente, il y a aussi l'humidité qui s'abaisse, parce que lorsqu'il y a le feu, il y a l'humidité qui diminue dans l'atmosphère. Donc, du coup, sur ces bases, on s'est dit, pour éviter des fausses alertes, il faut combiner plusieurs capteurs, soit des capteurs de température, de CO2 et d'humidité, pour permettre de faire une prévention plus exacte des feux de brousse.
During bushfire, the temperature increased and also the carbon dioxide rate. So they think about how, and the humidity decreases. So they think about how to use those sensors to capture data about these parameters for early detection.
So, if you were to make these products commercial, who would be your target user?
Si vous devez commercialiser votre projet, quel est le public cible des utilisateurs finaux?
Un projet peut être utilisé par le gouvernement, plus précisément les sapeurs-pompiers, les forces de l'ordre qui interviennent dans les cas de feux de brousse. Et aussi, ça peut être utilisé par
Your left hand, bring it down. Bring your left hand down.
pas de tierces personnes quand même,
No, no,
mais
bring it down.
par les
So look at the
sapeurs-pompiers
screen.
généralement et le
See your hand
gouvernement.
is appearing there.
Okay. So the government and those officers who usually have to control finance.
Okay, thank you. Merci.
Please call Team Cat from Ghana. Team Cat from Ghana. Team Kai.
Hello. Thank you very much. My name is Isaac Watson. I'm representing Team CAT from KNOS.
Good morning. Can you tell us a little bit about your project and why you chose to do this particular project?
Okay, thank you very much. So I would like to start with the statistics from some of the forums that we know. So according to Forum of International Respiratory Society, COPD, that is chronic obstructive pulmonary disease, claims about 4% of the world's population. And that is 2 million people. And only in Africa, we are having about 165.4 million cases. And Ghana alone, it is claiming about annually 5,000 people. And this is really, really disturbing because these people could have had the innovations, ideas of the problems that we are facing. But chronic obstructive disease is taking them away. So we choose to come out with innovation idea to solve the problem.
So if your product is to be scaled, what are the additional improvements you add to the product for it to be scaled?
Please,
Additional improvements, what will you add to your product?
Progress.
Improvement, yeah.
Thank you very much. So currently, we wanted to inculcate AI model into the dashboard to explain how the sensor values, the information they are picking, how they can be explained to individuals. So the additional one is to train models to understand what is going on at the dashboard side, so that individuals who do not understand whatever is going on, the AI can just explain whatever is going on to them.
Wait, come. Who is taking it?
What are some of the challenges
Where
that you faced in developing a
Yes, all
solution?
my phones are occupied.
Thank you very much. That's a
Doesn't
good
have
question.
a
One of the challenges is the sensor calibrations. We realized that when we were calibrating the sensors, we were not getting the accurate values. So what we did was to expose the sensors to the environment that have the parameters of the COPD, such as particulate matter. And then also we keep them in a safe room where we know that that place there is no the consequence of the COPD is there. So those that is some of the challenges we face, the sensor calibration.
And how did you mitigate those challenges?
Okay, thank you very much. So what we did was to make sure that the room that we are calibrating the sensors, that room is clean, because we don't have any valid sensor to check the values that the valid sensor is giving us. Or let's say standardized sensor is giving us. We don't have the standardized sensors to compare with what the sensors were giving us. So we make sure that we are in a clean room throughout the calibration.
Who is your ideal consumer for this particular type of product?
Thank you very much. So we are targeting agencies and institutions, and also mining sectors. Because they generate a lot of particulate matters, and then they should be alert when to wear nose mask, because you cannot just be putting the nose mask on every day, because it also has side effects. So the device is going to tell you when to put it on. So we are targeting the mines and other individuals also.
Just a follow-up question to that. I would assume that maybe many miners might not want to, people who work with mines might not want to wear any kind of a mask or protectant, because maybe it impedes them from maybe doing their work, etc. How would you compensate for something like that?
Thank you. That is a good question. So if people understand the effects COPD is bringing, then mines have regulations and rules that they set in. I think that one should be based on the mines to set a regulation for its workers. Because once you are losing the workers to some kind of diseases, it is actually reducing or restricting your human resource, because those are the people that are helping you to grow your business. So you should put down rules for them to follow. And that is where I think we should take it from. There should be rules for them to follow in the mines.
How does does your system receive data and transmit it? And also, how does it process it through your AI model?
Okay, thank you very much. But please let me first make some corrections. The AI model is the addition that we are going to have. So we don't have that one yet. So I'll start from the beginning. So we are using PMS 5003 sensor. That is for particulate matter sensor. So it uses the universal asynchronous transmitter and receiver. So it is connected to the RX and TX of the. We are using Arduino R4, which has a Wi-Fi capability. So when the information is received, the information is transmitted to the cloud architecture. We are basically using Arduino IoT Cloud. So once the data is captured there, you can receive the information from wherever that you are. So for instance, if institution like KNUST decide to purchase our device, the sensors capture the information, they send it to the cloud. So before the worker gets there, he has the notification to put on the nose mask before you get there. So the informations are captured and then they are sent to the cloud, and then we use a mobile phone or weather device to view the information the sensors are picking. And then also, we also follow one protocol, one communication protocol, that is the 12C communication protocol. We are using the AA219 sensor to check the voltage and the current state of the device. So one of the protocols that we use is the 12C communication protocol. Thank you.
What would the average cost of this device be if you were selling it on the local market?
Thank you very much. So that is 250 Ghana cedis, 2,500 Ghana cedis.
That's expensive.
Is there a reason why you priced it at that price point?
Yes, cost effective is relative. So I think for individuals you can target that amount for them. So we are looking at that as a general. It's relative because most of the mines company can purchase it when it is high, when they see the value of it. So I think cost effective is relative. So.
All right, thank you so much.
Thank you.
Please call Intellectual Powerhouse from Ghana.
Good afternoon.
Good afternoon.
Can you tell us a little bit about your project and why you decided to do this particular topic?
Okay, so I'll start from why we chose this project. So the project originated from the fact that I'm staying with my mom and she's a businesswoman. So usually she pays a whole lot of bills just to be able to get electricity for, because she's running a frozen shop power for the frozen shop so that the things in the frozen shop doesn't get spoiled or yeah. And then even after paying a whole lot of electricity bills to be able to get power for the two shops, we were also experiencing power outages with time. So the problems were the fact that we were paying a whole lot of money on electricity bills, and at the same time, after paying the money too, we were also facing power crisis. So then I'll proceed to what our project is about. So we decided to build a project called Power Hive, and then Power Hive is a hybrid renewable energy storage and management system. So it combines solar, wind, and power from the grid. So using IoT sensors and Earth observation data, we use AI to predict the weather conditions and make smart decisions. And yes, to predict the weather conditions and make smart decisions. And then also using IoT, we are able to monitor and control the power flow over the internet. So basically, Power Hive is an energy storage system with an integrated AI for the management.
So during the development phase, what are the issues you faced and how did you address such issues?
Okay, so I'll start with the communication. After taking the data from our sensors, and then we're supposed to transmit the data to the back end of our software. But then sometimes we were having trouble uploading the data to our backend because of the internet connectivity. That is poor internet. So we've optimized an offline feature which enables the system to store the data. And then once the network connectivity improves, it syncs the data to the backend, to the database of the system. So that means with the internet connection being steady, you have your readings, and then without the internet connections being steady, you still have your readings, and once the network has been fully recovered, the data is synced to your software. And also with the batteries, because our system is an energy storage system, we store the power in the batteries. The cost of the batteries that we wanted to use initially was very high, and that's the lithium-ion battery. So we managed to get the lead acid batteries because their prices are quite minimum compared to the lithium-ion batteries.
Can you walk us through how you implemented AI in your solution?
Okay. So you see, mostly when we talk about an AI within a system, we have so many forms of AIs. So for such a system like our system to be able to operate with an AI, we decided to go with a narrow AI. So the narrow AI is all of this. Okay, let me explain the narrow AI. So when you see the narrow AI, is just as the name implies, an AI which has been trained to perform a specific task. So in our case, our system has been trained for energy management. So we integrated open source models into the backend of our software, and then these open source models are able to operate using machine learning based on the power flow patterns, the communication between the system software and weather APIs, and the communication between the system software and electricity taxes APIs, because we also communicate with power taxes. So we are able to make decisions depending on the cost or the tax that has been calculated on electricity. Because we made a research and we got to know that electricity taxes mainly depends on the demand. That is, whenever the demand increases, the taxes also increases. And then mostly when the taxes decreases, when the demand decreases, the taxes also decreases. And that part is a smart feature that we've implemented, even though that scenario is not that common in our part of the world. But then because we are moving towards smart and sustainable world, so we decided to implement it now. For
decide when to switch from solar to battery or to grid?
Okay. So we have IoT sensors making, we have IoT sensors taking the sensor readings, and we have relays making the switching mechanisms. So what we do is we take the sensor readings, that is we take the readings from the solar panels, the readings from the power coming from the grid side. We also monitor the battery, so we know the battery's health, the battery percentage, and we also monitor the how much power you are consuming in your home. So, as I was saying, with the help of APIs like the weather APIs, the system can decide, or the AI can decide to switch to, let's say, the power coming from the grid, knowing that after going to the website, it's likely that it might rain tomorrow, and then due to data science and machine learning, our part of the world, we usually experience power outages, especially during heavy rainfalls, and then depending on some weather conditions. So that's for the weather side, and then depending on the battery's percentage, the AI knows when the battery is full and then when it is not. So assuming the batteries are full, the AI can decide to switch from the renewable energy sources directly to your home, so that you don't waste energy. Because when the batteries are full and then you are not supplying power to your batteries or to your home, in a way you are wasting energy coming from the renewable energy sources. And then in cases like during the night and then your batteries have been fully discharged, the AI can decide to switch to take power from the grid and then charge your battery, so that should in case you experience like an accident or something, you can still have access to electricity. So the switching mechanisms depends on the readings from the sensors and then the conditions like the weather and the taxes. So that's where the switching mechanisms comes in.
Who would be your ideal consumer for this project, and how much on average would it cost?
Okay, because we worked on an energy project, so basically energy is needed everywhere. So specifying where the project should go should depend on some factors like whether the person or the industry needs our services. For example, some people in agriculture would need such a system because someone who's running a poultry farm needs a consistent source of electricity. Because some systems like the incubators, they need electricity to survive. Farmers who harvest their crops and they want to preserve their crops during the selling process too, we are going to need a system that can supply you with electricity, a steady source of electricity, so we don't run out of electricity. Because who knows, anything can happen with time. Even if the power generating station doesn't decide to turn off the power, there could be a case whereby an accident will cause the power to go off. So it stands on agriculture and then education, like hospitals, because in hospitals too, sometimes you have some system that they use to preserve vaccines, and without electricity, all those vaccines are going to be wasted. And another example too is the fact that we are dealing with environmental monitoring too. You see, sometimes some people are working on projects which targets monitoring marine sites and coastal areas and such areas to install power from the grid to such an area. It might cost, yes, it costs a lot. Yes, so we decided to build a system that could survive with or without the power coming from the grid, using the renewable energy sources, and a smart grid, which is a digital brain, to help you optimize energy and reduce costs.
Thank you.
Please, when you go, can we invite pharaonic minds from Egypt?
University in Egypt. I'm representing my team, Pharaonic Minds. Should I start with the
Introduction.
We can start with questions first. Can you tell us a little bit about your project and why you chose to do this particular topic?
Our project is called SAR. It stands for Sustainable Agriculture from Recovered Harm. Its goal is to filter and clean out the pollution in places like rivers that are usually used for agriculture, as well as the pollution from air. And this cleaned water or air will be implemented in greenhouses in order to improve agriculture. Since these places are usually wasted, it's polluted, and so we aim to make use of it in order to not go to waste, as well as improve agriculture in Egypt.
So during the development phase, what were the issues you faced and how were you able to address such issues?
Okay. Some of the issues we faced were like in the automatic control of everything. Everything in our project is automatically controlled. There were obviously issues where sometimes things would not work properly. They were mostly solved with by fixing the code. Like we have pumps. Sometimes the pumps would not work in order. We also we faced some challenges with like raising the data to the dashboard. But we eventually solved it. We were able to fix the code for the dashboard. Like, are there any specific problems you want to ask about? Like, we faced multiple problems. Like,
I think just generally with the whole project.
like technical problems.
Any problems that you encounter?
What?
Any problem, any challenge that you encounter?
Any challenge we encountered? We encountered like there were challenges like there were not. I obviously said about the challenges we faced with the control and the data. I can't think of much challenges else. There were some challenges with water leaking. There were small problems, like there were not much big challenges, except the ones I talked about.
Okay. What are some of the ways you envision scaling these programs?
Yes. We obviously this project would help a lot in Egypt. Like in our studies, we saw that around 97% of the Nile River is used for agriculture and drinking water, and so we hopefully we could scale this project, which is not just a prototype. Like it will actually we use a filter in order to filter the water. We hope to scale this in order to use proper big filters that could actually filter the polluted water of the Nile, as well as the air. We use a simple air filter. However, to scale it up, we will use improved filters that could even filter out things we need, like carbon dioxide for the plants. We could also scale it up, in which we implement an AI model, which, as I said, everything is automatically controlled, but even this AI will be able to plant the water depending on the plants that we have. Like what we have now, it is a specific amount of water that is planted. Like whenever the plant needs planting, a specific amount of water. However, this AI model would be able to improve it in order that each plant could get the specific amount of water it needs.
Who would be your ideal consumer for this particular project? And how much approximately would it cost?
Obviously, the most ideal consumers are the farmers, since it mainly focuses on agriculture. the approximate cost, we estimated about like $250,000 for like the filter, for the filters and for like the greenhouse and for the entire control system. But obviously this is only like as a first step. Obviously if we hope to expand it even more, it would increase the cost even higher than that.
Okay, so how does your product receive external parameters and how does it help in the filtration of the water?
Okay, so we have sensors. We have two tanks. Tank that represents the unclean water and a tank that represents the clean filtered water after the filtration process. So we have sensors that take the monitor the readings of the filtered water, and these sensors are connected to an ESP microcontroller. They're directly connected. And so when the ESP takes these readings, it raises it to a web server that is then accessed by our dashboard, and so it's able to send these things wirelessly. And the dashboard monitors everything, as well as like if I wish to control it manually, I could do so from the dashboard. Without doing it so manually, it will be automatically controlled everything.
Okay, so what would you have done different if given the opportunity to rework on the project?
Excuse me, I didn't understand the.
What would you have done differently if given the opportunity to rework on your project?
To rework on it. I would try to, as I said about the AI model, I would actually try to implement it even on a small scale. As well as that, I would maybe try to even increase the options in the dashboard to make it more user friendly. So far, it's very good. Like it shows all the readings of the sensors. It gives warnings, but I can even show like signals that show us, oh, like this is working, this is not working. Like even each pump works. I could show like this is the filtering process is working, the non-filtering, the planting process is working. As well as that, I could try to increase the scale and make it so that the planting is done to multiple plants, not just one plant. So I could test out everything. If multiple things are working at once, how would it work?
Can you briefly take us through how you developed the dashboard? Just briefly.
Okay. We mostly just used like HTML
tell us, good morning, or good afternoon. Could you tell us briefly a bit about your project and why you decided to do this particular topic?
Okay, our project is called IncoFarmIQ. It's an AI-powered crop recommendation farm monitoring system that integrates IoT and Earth observation and machine learning to give farmers insightful recommendation for better crop yield and resource use. Our motivation behind this project was during our fourth year university, me and my friend went for a semester break to our home village, and there was a farmer sitting next to me. He was sharing us his struggle about his crop failing over and over the years. And in 2023, he planted wheat and it failed. The next year, he tried chickpeas and it still failed. And he and his family got into severe hunger. But that day he was returning from the agricultural institution, reporting about his farm and his crops. But behind the reason behind his crop failing was farming by guesswork and tradition doesn't work in a world that affected by climate change, soil degradation, and resource scarcity.
So how does your product work with EO data, and also how does it receive external parameters and feed to the AI for insight? How does your product work with EO data, and how does it read external parameters for the AI for insight?
Okay, that's a good question. The IoT sensors we use gives us the hyperlocal accurate data from sensors we extract from the swaps, and the second one as observation data gives us weather pattern like the weather forecast, climate, and vegetation health. And the third one is our machine learning model. After integrating the IoT, the data we get from the soil, plus the weather pattern and vegetation health and other parameters we can get from the EO data, integrating both, and after the ML processing, it will give intelligent insight. First, what crop to plant if it's not planted already. If it's planted, what's going on that farm? What is the status of the nutrient level, the temperature, the humidity, and if the moisture level is below the required amount. By processing the weather, the current soil status, the machine learning will give insight to irrigate. Our project integrates the automatic irrigation and fertilization system, so it can irrigate automatically and turn off after it reaches the necessary amount.
What are some of the challenges that you faced in developing your products?
Okay, the challenge we faced was the first soil parameter sensor we bought was malfunctioning. The dealer I trusted him, I bought many sensors, so I don't doubt him. I tried 4 days trying to get the accurate data, but I couldn't get the accurate data. After that, I decided to change the sensor. After that, it worked perfectly. Then after we get the telemetry data from the sensors we use, we have to send it to the backend server for the machine learning to process it. So there has to be some way. So we use ASP32. Then ASP32 cannot transmit the direct telemetry data to the backend server, so it has to be converted to JSON file format. So after the microcontroller collects the data, it converts to the JSON format, then sends it to the ASP32, then the ASP32 will send it to the backend server. That is.
A follow-up on that. What influenced your choice of the microcontroller you used? What influenced the choice of the microcontroller that you used?
Right. The microcontroller which was Mega, and there was a course called IETP in our university. It's called Integrated Engineering Team Project. We were working on a large project, and our teammates chose Uno, but it was limited and it was not
if your product is to be scaled up.
Our next move?
Yeah.
Our next move will be first, currently we are improving continuously. The week ago I participated on the Ethiopian National ID Hackathon and we integrated the national ID system to our system. So for better user data, secure user data. And our next step will be integrating LoRaWAN so that it can work on remote areas where internet is limited. After refining our process, we will scale it to industry graded level and deploy it across the nation.
After doing this project, what's one thing that you could take away from this experience?
This experience?
Yeah, with putting together this project, what's one thing that you learned from doing this project?
From doing this project, let me tell a story. My family always wanted me to be a doctor, but I refused. And I refused and joined engineering. So, but I had to help the doctors. So all of my projects are related with healthcare or agriculture. I came from a farming family, so they want me to be a doctor. They work on farming, so I had to help them with my career. So I think that's it.
Thank you so much.
Thank you.
If you go call Ghana team GCTU/XI. Waiting, what we want to do tomorrow is that as you listen to the students and the way they answer and the judges' question, the coordinators who are here, the 16 of you, tomorrow will set up on our page a poll, that means voting. So you, the coordinators from the 16 universities, will vote, but we are not going to use your results. It's just for us to compare and see. So tomorrow, 11 o'clock to 2 o'clock, where you will all see everybody's 5 minutes video. From teams from Ghana. No, we will not. So the 4 teams per university. Not per university. So if the 4 teams decide to vote for one university, it's a problem. Maybe they will all vote for you. So you will vote and then we'll tell everybody what the coordinators feel. The students who are not on that page, only you, the coordinators. So you will vote. You are not going to judge, you just vote. Okay, please, thank you. That's the African democracy. African, we take our democracy.
Good afternoon.
Good afternoon.
Can you tell us a little bit about
Galamsey has polluted over 60% of water bodies in Ghana, leading to in Ghana like the River Pra, which have caused water bodies to be destroyed and are being polluted with heavy metals and mercury. Alright. Now with this pollution going on, it has affected most communities and people, leading to chronic diseases like kidney failures, cancer, and death, with EP attributing this to about 28,000 deaths annually as a result of environmental pollution. Now, without smart real-time monitoring, agencies fail to respond to these issues, which causes the widespread of waterborne diseases like cholera and typhoid. With this disease spreading widely, it leads to about 502,000 global deaths annually by the World Health Organization. So with this, why do we sit down to let people die whilst we can do something? So as IoT enthusiasts, we decided to build a smart water monitoring model to help solve this situation.
So I noticed in your project you implemented a fish detection system. So could you help me understand what was the purpose of that?
Alright, so in our model, we have a camera on the model which gets to see the aquatic, which gets to see what is in the water. So with that, the aim was to study aquatic life in the water. And the purpose was to help scientists who study fishes to be able to have access to this data to help in their research. Whilst we have camera beneath, aside it detecting waste, sea waste in the water, we get to study the aquatic life also in the water. The scientists make use of this data to help them in their research. It's very, it makes it easy for them to have access because you don't really, it's very difficult to send divers in there to just be taking pictures. Whilst you can just have a device floating on the water body, just taking footages in the water.
So what specific water pollutants does our Sentinel target?
Alright, so this device is going to be deployed at Galamsey areas. Galamsey areas, mostly the water is being polluted with heavy metals like the cyanide. Mercury is also a cause of the water pollutant. With sensors like the cyanide sensor, pH sensor, temperature sensor, you get to understand or get to know what exactly is happening in the water. You have the pH level rising above 7. It's telling you that now the water is getting acidic. Let's go get samples to do further testing to find what exactly is happening in the water. With the pH rising, temperature rising, all those sensors, the values of those, the readings you are getting from those sensors should tell you something is wrong. And this is real time. So you don't wait to decide, okay, today let's go and check this to see if there will be something wrong. With this, you get prompt notification that something is wrong. Let's go get samples for further testing.
Have you and your team members thought about how or if you would implement this elsewhere in the world, and if so, where?
Yes, this is easy to implement and can be deployed anywhere to almost all to rivers, water bodies like the rivers, especially to Galamsey prone areas where legal minings are being made. Yes, and it's easy to add on more sensors to expand its functionality. So it's not just about pH level or temperature. You can easily add on sensors like the cyanide sensors and other sensors to help detect heavy metals in the water body.
What are some of the modifications that you've thought of to scale your product?
Yeah, adding on the cyanide sensors and other sensors to help detect heavy metals, getting strong. Okay, our device being on the water doesn't just stay there; it's not stagnant. It has propellers which helps it move on the water. So we have so the goal is to get strong propellers, motors to help it withstand the waves on the water and to move and to prevent weeds from also blocking the movement of the propellers as well. So the add-ons would be getting strong motors and propellers, more sensors to expand its functionality as well.
If you were to make this product commercial, who would be your target user?
Yeah, so the EP of Ghana, that's the Environmental
get to monitor from their headquarters or office. So when they notice or detect the abnormal values rise in the census value, they send their people to go get samples for further testing. They have all the tools to treat the water or resources. So we just provide them with real-time monitoring. So they get to know when exactly to go to get samples for treatment or further testing. So the main people to pitch it to is, or to send it out to, will be the DP of Ghana, the Environmental Protection Agency.
What were the challenges you faced during the development phase, and how were you able to address such issues?
Yeah, so the main problem we were facing was the propellers being blocked by the weeds on the water. So we went to a river to test our device, and we noticed one propeller wasn't moving, and it was as a result of a weed tied around it. Yeah, so to solve that, we had to get stronger motors to overcome that weed, because they're not able to move faster enough. If it's strong enough, it can move over it. Yes, so those were the challenges we faced.
One of the things I noticed after reading through your project was, that you would provide, for example, EPA or other governmental organizations the data to know when they needed to essentially treat that particular water body. But did your team have any interest in also treating the water itself? Does that make sense? Is that something that you have thought about, you and your team?
So our main goal was just providing them with real-time data. Just provide them. They already have the resources, enough resources to take care of the preservation or taking care of the water. Yes. So our goal was to provide them with real-time monitoring, provide them with actual data, know what exactly is happening in the water body. They then send their people to get samples for further testing and treatment. They already have the resources to treat the water and handle all those chemicals in the water. So we are just providing them with real-time data. They get to see what exactly is happening and know when to send their people to get samples for treatment.
And then my last question is, what would be an ideal cost of this particular project if you were selling it?
Yeah, so there's a low-cost project, very easy to implement, and will cost about 7,000 cedis. Yeah, because most of the sensors being used are low cost. But Raspberry Pi is the main project, the main device on the system. That's the Raspberry Pi.
What influenced the use of the Raspberry Pi in your system? What influenced the use of the Raspberry Pi in your system? Why did you go in using the Raspberry Pi in your system? Why did you use, instead of any other system, any other microcontroller or any other module, why did you go with the Raspberry Pi?
Yeah, Raspberry Pi. Okay, the Raspberry Pi is strong enough to handle multiple sensors. And we use the camera as well, webcam. The Raspberry Pi is easy to work with the webcam because of the USB. Using an ES32 would have been difficult because it can't handle the USB camera. So the Raspberry Pi is strong enough to take care of the camera and easy to stream the live feed of the video of the camera. Yes.
Thank you.
Please, when you go, call Mavericks from Ghana.
for something else. Machawali.
Please introduce yourself the way you are.
Okay, so good afternoon. I'm Isaac Bano. I'm from University of Ghana. I'm representing Team Margaret today.
Can you tell us a bit about your project and why you decided to pursue it?
Okay, so our project is about like measuring the water quality and it's geared towards fish farms here in Ghana. So when we started the project, we started looking at sensors we can easily get here in Ghana. That was related to like the environment. So after we got all the sensors, we just put everything together and we're like, okay, the sensors we have here, we can use to measure different, like the quality in water. That's like the temperature, the pH, turbidity, the total dissolved salt, and in water. Then we related it to fish farms here in Ghana. So there's actually a fish farm in the University of Ghana, like the fishery department. We went there and we spoke to the coordinator over there and asked him different questions. So our project was based on the fish farm they had over there. So we are working with them to build a system that will help reduce the fish mortality in their fish tanks.
How does the hardware side of things communicate with the software? The project. How does the hardware communicate with the software?
If I am understanding you correctly, for our projects we don't have like this basic coding. We are coding the sensors with, we are using a microcontroller ESP32. We are using the C++ language. So sensors are, data is being sent from the sensors to the microcontroller and being processed that way. We don't have any software like a website or an app, because when we spoke to the person over there, he suggested that we have our message, so data is sent to the farmers through SMS, no any website, because in Ghana it's easier to send messages through SMS. We looked at it in a sense in rural areas, they might not have access to internet to be able to access the website, to be able to check information like that. So it's being sent through SMS.
So how did you implement the SMS?
We use a GSM module, that's an 800L module, and we use an MTN SIM card to send messages. So it uses ATP commands to send messages and send and receive messages from the device to the farmer.
While working on this project, did you have any challenges? And if so, how did you overcome them?
Well, yes, we did. Calibrating the sensor, like the sensors, was one of like the biggest problems. Sometimes it works, sometimes it doesn't work. We need to get like the actual values that make it work. And if I'm to be honest, there are some of the sensors we were working with for the first time. So like the pH sensor, for instance, that was one of like the biggest challenges we had, because we are getting inconsistent values. It works this time, then at another time it doesn't work. So the problem was getting like the right set of the right number to multiply. It was dealing with the calibration. So through adjusting and testing, be able to get it right between the margin of error. So, yeah.
What makes your solution unique to other pre-existing monitoring systems?
Okay. So the reason I feel like our device is unique is because we added automated features to it. So we spoke to CSIR Institute. They also did a similar project, but the difference between ours and theirs is that we have automated features to ours. In theirs, if they want to add water, they manually do it. If they want to remove water from the tank, that one is also manually done. If they are checking for the pH sensor turbidity, it's done at certain times. But ours checks that like at specified intervals. And if there are times where like the water has to be drained or water has to be added, our device can detect that and do that all on its own.
So what would be the next line of action if your product is to be scaled up? Or what features will you add to the product if given the opportunity?
If we are to further to progressive, we'll add fish like a feeder to it, so the farmer just has to put food beside it, and the device automatically feeds the fishes on its own. And we'll also add a water filtering system, so that when the water is being drained out, it filters it and it can be reused.
Who is your ideal target user for this product, if you were to make it commercial?
Fish farmers.
Just fish farmers only?
Basically, yes. Our device is such that it can vary for any type of fish. So for catfish, for tilapia, any is fine. You just have to adjust the settings to it.
What sensors were being used and what was the reason for such sensors?
Okay, so as I said, we looked at different sensors that we could get here in Ghana that relates to the environment. So we use a temperature sensor, we use a turbidity sensor, a pH sensor, a total dissolve sensor. Yes, those are the sensors we use again. And the pH sensor is to measure the pH level of the water, the temperature sensor for the temperature, turbidity, and total dissolve.
Thank you so much.
Thank you very much.
Please kindly invite Team Futa from Nigeria.
Two.
Good afternoon, everyone. My name is Jayola Manuel from Federal University of Technology, Akure, Nigeria.
Good afternoon. Could you tell us a little bit about your project and why you and your team decided to do this particular topic?
Okay, thank you. In Nigeria, or let me say in Africa as a whole, flooding is a major disaster or natural disaster we do have. And judging from the past records, flooding takes a lot of lives, damaged properties, and even has done more harm than good in Nigeria. Example, in Lagos, which serves as the economic hub of Nigeria, we have a lot of records of flooding that takes lives, takes properties, and to rebuild those buildings or to make corrections on the
Take your time. Take your time. Breathe.
Sorry for that.
Yeah, it's alright.
Example, in Lagos, there are a lot of damages that has been done by flooding. We have it in Port Harcourt, we have it in Kogi State, we have it in Oyo State. The major reason we choose this project is to solve flooding issues in Nigeria.
So with your product, how can it be deployed to address that issue? How can it be deployed?
Okay. Our device is a node. What I mean by is a node is that we have an IoT on an iron rod that can be mounted at the coastal areas or coastal regions across the countries. It takes environmental parameters, send it to our web server, and from there we can make predictions. We can also visualize environmental parameters as they vary with time.
What are some of the setbacks that you faced in developing these products?
The challenges that we face are quite a lot. The first and foremost there is getting African data. It's actually disheartening that It's actually disheartening that here in Africa, we don't have African data to solve African problem. And that is one of the major reasons we face.
Still having challenges.
And that's one of the major reasons we face in general. We could not get an African data, environmental parameters that are taken in Africa for Africa and for use by Africa. It was very hard. It was very, very hard to get. It was very, very hard to get that data. We made an attempt to get data from Gmail and Africa, not, and we have to improvise by getting the data set from Kaggle, though it was not exactly what we wanted, but at least it was able to solve our solution. But next time we will work on providing African-based data that are measured in Africa for African and to be used by Africans.
Can you walk us through briefly the technical side of things, how your product receive external parameters and process those data?
So we have different sides. We make use of different sensors, starting from temperature, which implement use of BME and DHT22 and high precision temperature and humidity sensor. So the values from BME 280 and DHT22 were averaged to get average temperature, humidity, and air pressure. And also, we read other data like CO2, CO itself, rainfall, and other environmental parameters and we power this thing with a solar power device. It's a solar power device. We don't just and also we use that same solar panel to measure sunlight intensity because we believe that for this our device will give us exactly or to give the people exactly what they want. We don't just have to take data that's from the environment, and sunlight is part of the key factors that we need track rainfall, and to track flooding, and to track how the parameters varies over time.
Who would you say is your ideal consumer for this type of product, and how much would it cost on average?
The project is basically built for everybody. Number one, our major consumer that we are looking at is the Nigerian government, the NGOs, Ghana government, all countries that fall under West Africa and Africa as a large. So we really want them to deploy this in core areas or core states that brings a lot of, that contributes a lot to the GDP of the country. Example, in Nigeria, Lagos, Port Harcourt, or your state, they contribute a lot to the GDP of the country. But yet, people living in that state, they are not safe, especially in Port Harcourt and in Lagos. To build the device, it costs around 300 to 310,000 Nigerian naira, and that's to set up the whole infrastructure. But to make a single device, IoT device, the 300 I'm talking about comprises of the IoT device, the ML, everything. But to build other nodes that can connect to our existing AI and our existing model, it takes less than 100,000 Nigerian naira.
What are the improvements or core features you add to your projects when given the opportunity to advance on it?
Okay. The first thing I'll talk about is I will try as much as possible to eradicate the presence of internet. Instead of using internet, because that's one of the major problems that we had, because you have to subscribe to the same kind of movie that you are using. So instead of that, I've made some research and I can make use of other microcontrollers or other microprocessors that are available and I can communicate directly to the satellite instead of relying heavily on internet. And also, I'll work better on the AI models. The models we currently use were based on Gemini 2.0, and if we can build our own model from scratch using African data, that's one of the things that we want to work on as well.
Okay, thank you very much.
The Zoom.
So let's try and say, do you have the link? So please, if you can call Uganda to be Yes, so we are going to Uganda. So we go on Uganda and then we'll finish, stretch our hand. The ambassador is on his way, then we have a opening closing ceremony, then we are done for the day. For those of you who want to visit the University of Ghana, Dr. G. Lambda, please let us see you. You will talk to us how they will be going there. It's an engineering master. If it's available, is it available? No, but is it available? If it's available, apart from that, so we'll see how much of you can visit the University of Ghana. Why Dr. Ruya, but they want to go to visit with you. Well, the University of Ghana, Ghanaians, you want them to go to 6 hours to your university. 6 hours in, 6 hours back. 8 hours, okay. Yours is about 5 hours. 6 hours. So we choose 10 minutes, 6 hours, 8 hours. Please, when you're ready, let me know for Uganda. We don't need to do streaming. Have you gotten a battery? Jerry? Oh, sorry. So the microphone should be here. I need to sit there and then reconnect. Anthony, your man has dressed very well.
Immediately I'm centered and everything is on the screen.
No. You're not centered.
Hello?
He has to go up a bit. You're not centered. No. I cannot see his face. His face is not showing.
Online.
Go down a little bit. Go forward a little. No, still.
Back. Back.
Okay.
Back.
Harun, welcome to Ghana virtually. It's unfortunate we couldn't get you to join us. Am I muted? Hello, can you hear me? Unmute. not the screen anyway. So you've been following on YouTube, great. So these are your judges. We are going to put it in front of the judges, and they will take turns to ask you questions. We introduce Patrick from Kenya, Augustine from Ghana, Edenway, and then Justin from the US Embassy Accra. So they will take over from here for the next 5 to 10 minutes.
Thank you. Hopefully you're hearing me clearly.
Yes, we can hear you. We're just trying to make sure that it's connected to the microphone.
Okay.
Can you say something else, please?
Hello. My name is Aaron Otwa. Good afternoon. My name is Aaron Otwa.
No, you can't continue.
Thank you for joining us today. Could you tell us a little bit about your project and why you decided to do this particular topic?
Thank you so much. My name is Aaron Otwa. I'm from the Uganda Makerere University. That's the next global team. So our team designed developed a smart irrigation advisory system, a system that helps advise farmers on when to apply water, when to irrigate, and how much they're supposed to irrigate. Now, this
Where's the camera?
came as a result of
Won't you take the pictures?
90%
No, I'll take you on the bench from
the
once I take
farmer
you.
or the farm are rain-fed, and if agriculture really employs about 70% of Uganda's population. That means that large portion of the population depends on agriculture for its survival and for us part of its economic activity. Now, as a result of this, most of this, like I said, 90% of our agriculture is
Please start preparing for the charge.
Is a point. So to overcome that challenge, my team and I decided that instead of just picking a point, to buffer that point, to make sure that the element of spatial variation is scattered for, so that we don't have either the data being overstretched and getting wrong results.
Is there anything that I guess what is the biggest takeaway that you've learned from putting together this project?
The biggest takeaway is that one, when we're developing any system, it should be developed we should be putting in mind the people that are going to use the farmers. So developing based on simplicity, very simple, and two, those are
There's a microphone on the podium. No, leave it there, leave it there.
and why we push all our calculations in the cloud is because even the simplest phone, smartphone, is able to use this because there's no end calculations that are done on the device being used, but rather all the calculations are done so that is being well so that the devices are not stressed, but also the system remains as simple as possible.
All right, thank you so much.
Hello. No, no, this way. This way. No, no, that way. Back. Yeah, drop it. Perfect. Yeah. So this. I should follow all the right? No. That's the strategy. That man is for you follow. Okay. But you can take the shot from somewhere here because we already have that camera there. Okay. And then when I switch, I'll give you a signal. You go to the other side and take from there as well. Okay. Right? Yeah. So you're taking from side and side. You leave this camera in the center. Yeah. So he's always focused. Right? Okay. Pardon? There's fine. Yeah, the camera is right in front of you. Yep.
Okay, distinguished ladies and gentlemen, all too soon we've come to the end of today's session where we took our participants.
There's nothing wrong with the image. There's the lighting.
of
The light is coming from there. So go and shoot from there.
We're going to have a closing ceremony. And we have here the
Come.
US Embassy.
No, leave it. It's there.
So he is the keynote speaker to close this session. And before we do that, normally there will have been a opening ceremony and a welcome address. So we are combining all to open and close at the same time because innovation comes with uniqueness.
Yes.
This is a unique one. So on behalf of Edenway Foundation, my name is Professor George Weafi, the founder of Edenway Foundation.
Okay.
We set up the Edenway Foundation for one purpose. That is to provide support to the youth of Africa. I think we are the largest population when it comes to demography of the world. To give these youth that support in technological innovation. So Edenway Foundation is established in the central region where we have 100 acres of a tech village. Last year, in partnership with the Marine and Coastal Areas Management for North and West Africa, which we call MACNOA, we implemented the first edition of GAIAthon for North and West Africa. And this is the second edition for all of Africa. Last year, we have over 400 students coming in. This year, when we launched it in November, we had over 700 students who registered to be part of it from 16 universities across Africa and 12 countries. They formed teams of 3 and 4, and we had 123 teams. And these 123 teams, they pitched, and we shortlisted 45 teams from the 16 countries. And then we have here the final 15 of the team. So from 123 to 15. So it means we have a good crop of African intellectuals who are pitching for the Continental Award in 2 tracks, digital innovation and then smart IoT systems. So we've gone through all that and we're bringing today's session to a close. So we welcome all of you from your various countries to Ghana. Edenway Foundation welcomes you, and we hope that you have a wonderful time in Ghana for the 2 days that we are going to have the GAIAfest to award winners. On this note, I would like to invite Mrs. Justin King, who is the Deputy Director for the Environment, Science, Technology, Health Hub of the U.S. Embassy. Please.
Good afternoon, everyone. First and foremost, I think we should just give a round of applause for all of the innovative solutions that you have all I think I can speak for myself and the judges that we've witnessed incredible creativity and dedication from you young innovators. So we're really excited about that. As Professor Weafi mentioned, my name is Justine King. I am the Deputy Director for the Regional Environment, Science, Technology, Health Hub here in Accra. Our office covers West and Central Africa, so we cover about 24 countries. Part of our work this year has focused tremendously on science and technology, and so we were really really excited at the opportunity to collaborate with the Edenway Foundation on issues like Earth observation, Internet of Things, data integration, to help solve a variety of issues that you are facing in your respective countries. Ladies and gentlemen, as we bring this inspiring program to a close, it's my honor to introduce the Chargé d'Affaires, Rolf Olson, of the U.S. Embassy in Accra. Mr. Olson is a career Foreign Service officer. He assumed direction of the embassy in May 2025 after serving as Deputy Chief of Mission since 2023. He brings deep experience advancing U.S. partnerships across Africa, including Nigeria, Djibouti, and now Ghana. Please join me in welcoming Chargé d'Affaires, Rolf Olson, to share his thoughts and congratulations on the remarkable work you've accomplished and the bright future ahead for innovation in Africa.
Thank you so much. It's a great privilege to be here. Justine, you forgot to mention I was a great boss, too. That's a part of it. Terrible. Well, thank you very much, and thank you to Professor GAIA, founder of the Edenway Foundation. Really extraordinary foundation you have, and work that you do to compile all of this. It is always complicated to bring together a multinational endeavor. It's complicated to do a national endeavor in any place, but then you start bringing an international perspective on it, and it makes it much more complicated. And so, congratulate you on that. It's really, really, really impressive. We really appreciate it. Before we go further, I do want to just take a moment to note that we honor the recent and profound loss that Ghana has endured with the helicopter crash of just less than 2 weeks ago. And last week, the nation bid farewell to several courageous and devoted public servants, including the Honorable Minister of Environment, Science, Technology, and Innovation, Ibrahim Murtala Mohammed. Minister Mohammed's vision and leadership played a vital role in advancing Ghana's progress in science, technology, and innovation, and he had a lot more work to do in this new administration. And his dedication to these fields has left a lasting impact on his country. And so while his absence will be felt, deeply felt for a long time, we take comfort knowing that his capable and committed team will continue to pursue his mission with the same determination and purpose that he embodied. It is wonderful to see all of you innovators joining us today from all across Africa. The creative energy here is extraordinary. And talking with Justine beforehand about everything that you've been working on, I'm deeply impressed by all of that. Have great respect. You know, she was mentioning we've seen solutions that have pushed the boundaries of what's possible. Leveraging Earth observation and artificial intelligence and the Internet of Things to address some of Africa's most pressing challenges, from water pollution to energy access. Your creativity, skill, and commitment to improving your communities is exactly what the future of Africa's technological ecosystem needs. At the U.S. Embassy, we spend a lot of time trying to promote STEM issues. We've got a STEM event in our American corner in Boba on Thursday, and a mathematics lecturer from the University of Ghana will be at our American Center at the Embassy, leading a program on math beyond numbers. We hope that you can be a part of it if you're here, and then in many of our home countries in American spaces, we have similar programming that goes on. Congratulations to the 15 brilliant finalists emerging from 123 teams. 123 teams from universities across Africa. I understand, of course, we have 4 from Ghana, and then we have representatives from 6 other universities. Cote d'Ivoire, Nigeria. Where's the Nigerian team? What state? What state are you from? State. Nigeria. Lagos? Okay. I have served in Lagos at our consulate there, so Ekaro to Nigeria. Togo, Senegal, Benin, Cameroon, and 6 from within the region, within the West African region, and As you know, this year's theme was advancing innovation with Internet of Things and Earth observation. And today we celebrate your great ideas on the continent using science and technology to solve real-world challenges. Some of the projects showcased here are crop production by integrating data and analytics, using Internet of Things to develop autonomous smart water monitoring systems for monitoring water pollution and ecological degradation, and using AI and IoT to create autonomous hybrid energy systems, optimizing energy generation to ensure communities have working electricity. Obviously, an incredibly high priority. Science, technology, AI, and cybersecurity are top priorities for the United States, and probably comes as no surprise to you.
You
And
can add
supporting
the live
initiatives like
streaming
GAIA
so
aligns
it's
with
in the
our
Bedou's
commitment,
group.
to global scientific collaboration and innovation-driven prosperity. This benefits both Ghana and the United States, all of your countries as well, and of course the entire world. We are proud to lead globally in science, technology, and AI, and we're equally proud to share our expertise and platforms with our African partners. From NASA's Earth data to U.S. startups pioneering smart systems, the American innovation ecosystem thrives on openness, collaboration, and ideas just like the ones that we see here today.
So please get
And just as Ghana has had
for
a new administration since January, with the president who agreed to serve a term in office, so too we in the United States as well. And the Trump administration has been seeking to reorient U.S. relationships with African countries toward investment and commercial partnerships. That's a really important part of our administration's priorities. This includes commercial diplomacy in our engagements, as demonstrated by the president's hosting of 5 African leaders recently in the White House, and our strong U.S. government presence at the Corporate Council in Africa, U.S.-Africa Business Summit in Angola a few months ago. In Ghana, there are more than 100 companies, 100 U.S. companies present doing business across many, many sectors. And U.S. companies are eager to explore more business in and with Ghana. That is no doubt, we hear it all the time. I joined Google last month for the launch of its Artificial Intelligence Community Center in Accra, at which they announced $37 million in support for research and innovation in Africa. The potential continues to be tremendous in Ghana, but in the region writ large. And we are also cooperating, the United States and Ghana, on cooperating on civilian nuclear energy with U.S. companies Regnum and NuScale, working to deploy small modular reactors developed by NuScale. In January, NuScale opened its energy exploration center in Ghana, the first in sub-Saharan Africa. Through this partnership to share technology, establish regulatory frameworks, and build skills, Ghana could become a regional hub for SMR expertise, small modular nuclear reactor expertise, as we seek to harness the power of nuclear energy for the benefit of Ghanaian people. We're really excited about the technological possibilities of this, and indeed what it could really mean for Ghana as a center of excellence, as something that could really help drive the economy. As many of you probably know, some of the great limitations on industry exist because there isn't sufficient power supply. So that's something that we're very excited about, that possibility. So in closing, let me just say to you all finalists, your ideas have power. I suspect that you're already aware of that, but I just want to emphasize how important that idea is. The work you've done doesn't stop here. In reality, it's just the beginning. Whether you're working on satellite-based policy tools, IoT-driven environmental sensors, or digital environmental platforms, your innovation matters and can, and in many cases will, make a real difference. We at the embassy are proud to support your journey, and we really can't wait to see how far you go. So again, congratulations on getting to this point. Congratulations on this excellent program, Professor, and we wish you all the best. Thank you so much.
Thank you very much, Excellency, and also for your kind words for all of us. And we believe this collaboration will grow into the future. Since you are here, Edenway Foundation is here, we hope to be having more of this collaboration. Thank you very much. And on this note, we'll be taking a group photograph. Who is helping us? Is it Edenway staff? Ezekiel, where are we taking a group photograph? Can we do it here? Okay, so we have our backdrop, so if we can remove this one, we'll use that.
Okay, we can take this off.
We'll take this, we use, then we can project the GAIAfest logo, and then we can have a seating so that we can all be able to. So if we can put some few seats in front, then won't this be a problem? And we also, can we crowd? So this one will be right in our faces. So we can
Next
sit
up.
here.
I think it's your screen.
So if
No,
please
I
can we
think
bring some chairs here
it's
so
this
that the rest can stand and then we can have
screen too.
Let's bring some chairs.
Please, can we put some chairs?
Okay, you, I don't know, you be you can stop.
Can we get the other back?
No, we shouldn't go all the way around the camera.
Let's get the
If
other
we
back.
can come and then.
Yeah, bring. Danny, zero. Bring Then there's one more pull outside. On the left side when you get out of the door.
The tall ones will go to your back in the shop. Dr. Runia, please, let's have our coordinators arrange. Dr. Runia, please, Professor Harriet, we only get a female, please, you are very tall. No, please come here. Let's leave the three here. Please sit down. Please sit down. Okay, please, if we can all handle and the back together. Let's put one student. One young female student there.
Someone to stand.
So please, the rest we can stay at the back. Cameraman, that's where the cameraman. He's coming. Please, those over here. Please show us the best way to go. Is it okay now? We all have to be in. say something like Gaia. All right, good. All right.
There's too many young people in there, but everybody's like, it's up, Gaia, oh my God. Give us some flair. Let's say Gaia. GAIAfest. Oh, people are just thinking GAIAfest.
Thank you. Thank you so much. We have one more thing to do, please. Mr. Ambassador, we have one more thing to do. So, cameraman, where are you? Please, if you can come back a little bit here, sir. Please bring your camera.